All right, you're listening to the Maker's Quest podcast. I am Brian Benham.
And I am Greg Porter. Today, we are going to be talking about the fudge factor and how and where we account for, and maybe even do a little bit of hiding of our mistakes.
Yeah, so what made me think of this topic that would be a good topic is I was watching your YouTube video as you were inlaying this segmented ring into the top of a guitar, and you deliberately set it so that where if there's anything off, that it would be hidden under the bridge.
Yeah, and it was interesting when you reached out to me. I knew exactly exactly what you were talking about. When you're using several different machines or several different fixtures and trying to get things to fit, and when I say fit, I mean like a snap or press fit where it's very tight tolerance stuff. I'm not going to say that it's impossible to do, but it takes so many revisions to get it perfect that sometimes as designers and sometimes as builders, we need to build in, or we need to find the place in that design that we can adjust a little bit to make up for that tolerance. And I think, just thinking back to that, as I was making those pieces and parts, I had my calipers out and I was within just a few thousandths of an inch in terms of size for that rosette that I was making. And that rosette was 24 different pieces glued together. No, it was more than that. It was 36 pieces glued together in a circle. And when I was making those pieces, the tolerance between pieces to get a nice round circle and all of that, it was its own sort of little math problem, or maybe not math problem, but puzzle that I had to figure out. And then as that fit back into the soundboard of the guitar that I was building, then that soundboard was something I cut 2 months ago, probably something like that. And then you cut another piece on the same CNC machine, but maybe the temperature's different, whatever, the machine hasn't warmed up, and the tolerance are just off enough that there's a little bit of variation in the dimension. And as I was starting to put it together, I was like, oh, come on, dummy. You've got a fretboard extension that's going to cover this, and it doesn't have to be exact. So if there's a place to hide it, let's make it fit really, really well, instead of making it snap in perfect and risk over sanding a part or ruining a part because you're trying to make it absolutely perfect. You've got an opportunity to have a little bit of that fudge factor, as it were. Use it. And I think it's an interesting way to approach our work. I know in your carpentry, you have to have similar situations where, I've got these parts, and maybe I've got 5 or 8 or 10 parts, and they're all going to make this whole, but I have to find a way that if there's a tolerance error, that I can account for that.
Yeah, when you're like fitting a drawer, we were talking offline just before we hit record about fitting a drawer um, to leave just a little bit of a gap all the way around. And if you're doing what's the style I'm thinking of where it's all flat panels, a European style uh, drawer front or something where all the drawers are stacked on each other. If you cut all the drawers at the exact same length and then you go to install them, you might end up with this huge gap at the top just because it might just be less than a 64th of an inch off on each drawer. Each drawer face might be just a 64th of an inch smaller than what you thought it was. And that added up all the way up to the very top to where there's a big gap. Another thing, like when you're cutting joinery, if you want your joinery to be really tight, use a marking knife instead of a pencil, because then you have an exact place to drop your chisel in to cut your joinery instead of this big, wide, thick line from the pencil.
I feel like the older I've gotten, the more apt I am to pick up a marking knife or a scribe versus a pencil or a pen. And almost never do I pick the Sharpie up anymore. And I look back when I was doing work on cars and butt fitting panels together, which is one of the most difficult things you can do weld two panels that fit perfectly together out of a car skin that you had to cut a hole out of, right? The tolerances to fit them back are incredibly small. And I would use my Sharpie to make my marks and cut to the inside of the Sharpie line, right? And I think back to that now, and it's like, oh man, what I wouldn't give to go back and give 24-year-old Greg some advice to buy a really nice scribe and forget the Sharpie markers.
Yeah, for sure. That pencil line thickness of that Sharpie marker, that thickness of that pencil line can really screw you up. And especially if you want to cut out a whole bunch of parts all exactly the same, and you measure and mark each one, but if you mark it just a little bit to the left or the right of the line on the tape measure, that could throw it off, or just the thickness of that pencil line, and you go cut them all, and now they're all a little bit different. So one thing that I've always start to work into my work is use like a stop block, so that every time I set that part against that stop block and make a cut, it'll come out exactly flush with the last one. They'll all be exactly the same.
So what happens, Brian, when you are doing a stack of drawers like that have very tight tolerances, and you get done and you do have that gap, or you have an overage or something that isn't to plan, so to speak? What's your first course of action to get that back within tolerance, whether that's visually or whether it's from a measurement perspective?
Yeah, so on drawers like that, I'll like a European style drawer where they're stacked like that, I'll start at the bottom drawer and work my way up to the very top. And then the top drawer, I'll build that separately last, and I'll just measure that space and custom fit that last drawer to the very top.
Oh, so the top drawer is sort of your shock absorber, so to speak.
Yeah, yeah. So I'll set up my jigs and I'll build, if it's like a stack of four drawers, I'll build the bottom three all exactly the same. And then that last drawer, I might leave a little bit wide so I have room to shrink it down or cut it down or fit it or whatever.
And that's something you do at the onset of that work. It's not something that, as you get to the end of it, oh crap, they didn't fit just like I thought they would. You're expecting that you're going to have to absorb some tolerance in there at some point.
Yeah, my younger self would have not have thought of that, but I have screwed up enough things now that I can plan for that. And a good example of my journey of screw ups is uh, for a while I got into wood turning and segmented wood turning, and so the miter saw, the chop saw, is just a really quick and easy way to cut an angle. And so I built this little jig to safely hold the little parts, each little segment, and just set up my miter gauge and cut them all. And when I go to put that circle together, there's always this big gap somewhere in that circle because each one wasn't perfect or wasn't precise, and also the miter saw wasn't very precise. So then I moved to the table saw and got even more precise, but there was still always that gap. And a lot of wood turners fudge that gap by they'll glue up half the circle and then glue up the other half of the circle, and then they'll sand um, the two halves until they fit tight together. And then
Yeah.
now that I've even done even more research and have really tried to find wood turners that are just like master wood turners that really know their stuff. One guy showed me a jig called the Wedgie Jig, and it's basically a wedge that you cut out on a CNC machine, so it's really high accurate angle. Like there's no fudge in this angle at all, and you cut one side, cut the angle of your segment on one side of the wedge, and then you move your piece to the other side of the edge, and so that angle, even if it's a little bit off and not perfectly lined up with the blade, since you're switching back and forth between the different edges, they cancel each other out. And since I built that jig, they come out perfect every time.
Yeah. I can't tell you how many times I've watched Frank Haworth or Kyle Toth do a segmented bowl, and almost invariably they use the same approach that you're talking about, where you make it in halves. and then you sand the edge, those mating edges of the two halves. And that way, whatever weird little fudge factor that you have, you're able to absorb that. And quite honestly, with the rosette on the acoustic guitar, that was the approach that I took. I knew with that many segments and
Yeah.
that many chances for error, modes of failure, if you will, it's like there's no way that little Greg Porter is going to nail that sucker. And my instruments, I guess when you're looking at the angle, so it was basically a 12-sided segment that I was working on, right? And that's a 60-degree angle or a 30-degree, whichever way you want to look at it. And you can measure that on a table saw, but you can't measure it to the 100th of a degree. And when you get 36 pieces that make up that 12 segmented piece, the margin for error is so small to get it right. And that goes back to, I stuck two halves on the table saw and sanded them perfect, and those edges came together. And then it's okay. Now that's supposed to snap into a recess that I cut 2 months ago. I'm got to have a little fudge in there.
Yeah, especially since the humidity has changed, so that thing, the recess you cut 2 months ago, is not the same size anymore because of wood is always moving.
That, and one of the interesting things that's always, I don't know if it's perplexed me, but it's been interesting through my, I guess you would call it my maker life, which has been since I was a little kid. When you start out woodworking, you're not gluing super small pieces together. You're gluing larger pieces together. You're making panels, you're making boxes, you're gluing together things of some fairly large dimension. And I feel like the further you get into woodworking, the more likely you are to start gluing very thin, small pieces together. And the smaller your piece, the greater the expansion from the glue. And that glue joint, just the fact that there's a joint there at all, starts to affect the dimension of the piece you're working on when you get into some of those small things. And we're talking, I'm gluing together, I think those pieces were less than a 16th of an inch thick. They were pretty thin pieces, just little wafers getting glued together. And just that glue starts to make that piece swell just a little bit. And it can swell over time as it's drying as well. And one common thing in the guitar world is, people will buy rosettes that are already made, and then they'll do it just like an inlay, right? So they'll mark it out, they'll route it, and they'll fit it in. And the second that it touches the glue that they've put into that recess, the whole thing starts to expand and it no longer fits. So it fit dry perfectly, no problem. And it's not because the glue took up room. It's because the wood is expanding as it's absorbing that glue. And it's literally, it's a timed event for sure. So if you can get it down and in the recess, it's going to stay there. But if you can't, then it's just going to explode on you and you got to pull it out and cry a little bit.
Yeah. Yeah, that reminds me of another example of leaving a little fudge factor. Like when you're gluing up a mortise and tenon and you put the glue on the mortise or in the mortise and on the tenon, it fit perfectly together. And then now all of a sudden you have to drive it together with a hammer or pull that joint tight with a clamp because that glue swelled up. And then sometimes other bad things happen is if you put a lot of glue in there and you force that tenon in that mortise and it's so tight that there's no place for the glue to go, that pressure from the glue will push that board back apart if you're not careful. So sometimes I'll go just maybe a 16th of an inch extra deep on the mortise, just to make sure I bottom out and have room for any excess glue to go. And that way it doesn't, there's a name for that, where it pushes that back out, but I can't think of it. But yeah, you got to have a little bit of fudge factor in your mortises, but you still don't want it to be so loose that you don't get a good glue bond because then your mortise fails.
I did a series of inlays with my CNC machine several years ago. And it was me just trying to understand how to use the software, how to use the machine, how to get a good tight fit and high tolerances. Cause I wanted to do some type logos and type in inlay form that were, fairly small, like maybe the size of a silver dollar, but there's text inside of it, really small detail stuff. And that was one of the things that I found is if you didn't leave room for the glue, if you didn't leave a cavity between the inlay and the baseboard, I don't know what the right term there is, but the plug in the hole, so to speak, if you didn't leave room between those two, there wasn't enough pressure in the world to squeeze those two pieces together. There was so much, I guess it'd be hydraulic pressure, right?
Yeah,
You
that
could,
was the word I was looking for.
you could get the air to escape, but the glue couldn't move through the pores of the wood. The hole is too small for the glue to get through. And, I don't remember how many clamps I had. I thought, oh yeah, this is as tight as I can possibly get this sucker. And, the next morning you go and unclamp everything and it's, a solid 1/8 of an inch from bottoming out. It's like, wait a minute, what happened? And it took some serious experimentation to finally land on a spot where it's like, you have to have enough glue to cover the mating surfaces or they won't stick together. You'll get the inlay moving sideways at an angle, which is no good. But you had to have enough glue, but then you had to have a large enough reservoir to account for all the extra glue. And oh, what a series of experiments that was. Boy, it takes a fair amount of time to cut one of those inlays on a CNC, and then to see them fail over and over and over again is really frustrating.
Yeah, that reminds me of a collaborative job I did with James King Fine Woodworking. I don't know if
Mhm.
you've seen his YouTube channel. He does some really cool stuff. And he didn't have a CNC machine at the time. He might have one now, but he wanted to inlay his client's logo into the top of this humidor box. And he sent me the logo for the file, and I was like, yeah, I could do this, no problem. And it was my first time I'd ever done an inlay, but on the CNC. But I knew I could figure it out. Like I've seen other people do it. It's something I should be able to figure out. It's generally how I approach most of my life, is a series of failures. Just because I saw someone else do it, I think I can do it too. But I I went to work at it, and the first one, the tolerance was so tight it wouldn't go together. So then I cut another one, and then that was too loose. I didn't have a frame of reference of, well, how much should I leave? How much tolerance should I tell the CNC machine to leave so it'll fit together? So it took me 7 or 8 tries of just slowly moving it in a half a thou at a time or a thou at a time until it finally just like popped in place. And then, of course, then once I put the glue on there, I was like, oh man, I've got to work faster here. It's getting tight. But yeah.
Yeah, there is a very steep learning curve to that process, and definitely an area where you have to consider again that fudge factor. Where can I let this go? And one of the hard fast rules that you'll see in marquetry and a lot of people who do CNC inlays is using tapered bits to cut the plug in the hole so that they slide together, and you've probably got an overlap of 20 or 30 thousandths of an inch, that if it doesn't go in all the way because the fibers of the wood expand with the glue, well, you got enough of a fudge factor there to make it look right, even though it's not an airtight fit when you're cutting it.
Yeah, that happens a lot when you're doing like hand cut dovetails or through mortise and tenons that you're doing a hand cut. Undercutting the joint in a non-visible area is something that's very common. So that way, when you do push it together with glue, it doesn't split out your pin board or tail board or whatever.
I've seen an awful lot of folks. I've made some really large box joints in my day, but I've never done the 1/8 inch thick box joints that you see a lot of folks do. So they take call it the width of their saw blade on their table saw, and they make box joints to that. But I've seen so many people attempt that and not figure in the space for the glue, or they have to creep up on how much room do I really leave? Is it 5 thousandths? Is it 10 thousandths? What is it? And you have this really great fitting box joint, and the second you put glue in it, there's no way in hell that you can get the two pieces put together. They're just repelling each other like the same ends of a magnet.
Yeah, that's also a good example for a cumulative error. Like the first time I did a box joint, I was like, all right, well, I 6 inches wide, so if I make each box joint a half inch, it should all come out perfectly even. Well, it was just not quite a half-inch gap between each finger. It might have been just a half inch plus a thickness of a piece of paper, and I cut all of them. But then by the time I got to the end, that last pin was narrower than the rest of them because it just added up. That little piece of paper kept adding up over the 6 inches. So then all of a sudden, my last pin was like 3/8 of an inch wide instead of a half inch wide. So the whole box looked dumb.
Well, it's interesting. You mentioned a term called cumulative error. And in the machining world, you hear people talk all the time about stacking tolerances. And that's very similar concept, or the exact same concept, just one's probably applied to carpentry, one's applied to the machining world. And where you'll see it in machining is every print that's drawn has a tolerance associated with it. So this part is plus or minus 1,000th of an inch, or plus or minus 5 thousandths of an inch, and sometimes to the 10 thousandths of an inch, so plus or minus 1/10 or 2/10. And if you stack 5 parts together and they're all plus or minus 5 thousandths, well, that's a 10 thousandths of an inch range. I mean, that's as thick as your fingernail. Well, if you have 5 parts that are 10,000, well, all of a sudden you're at 50 thousandths of an inch, which is almost a 16th of an inch. And in the machining world, where things are very tightly fit together, a 16th of an inch might as well be a mile. You're so far off from your target
Yeah.
that things aren't going to fit together. And you're talking on the manufacturing side. If you have a nut or a threaded section of the piece you're making, and you stack these pieces together, and it's got to be tight, but not too tight because it has to spin within that, or there's some other function, a sliding function or something, where it's just got to have a thousandths or two gap. There's no way to get that tolerance without that fudge factor piece. And you'll see a lot of factories. I think John Grimsmo is a knife maker on YouTube, and if you watch John's videos, he's a machinist. He designs these incredible knives, and at one point he was making I think it was the locking mechanism for his knife. And they would make parts, and they would measure every part, and they would put them into a bin. This one's plus 1,000. This one's plus 2,000. This one's plus 3. And as they were making knives, they would start to fit one piece in there that took up that tolerance. So they would match the parts that they had made with the tolerance differences. And some of that would be, when he spins up his lathe for the first time, it's making parts that might be a little smaller. And then as the lathe heats up, those parts get a little bit bigger, or vice versa. And all of a sudden, he's got this bin of parts that he can match the part with the tolerance that it needs after everything's been stacked together. I don't know how many parts he puts together to make a knife, but I would assume it's a stack of somewhere between 5 and 10 parts. And you got to be able to take that up, because his selling point for his knives are just the precision. Like when you open them, everything clicks, everything feels perfect. It's this very precise, it's like shutting the door on a Mercedes. There's just a different click when you get to that level of tolerance. And that's his way of accounting for that fudge factor. At least that's the way I've seen him do it. I'm sure he has multiple ways of doing it, and he's probably much more sophisticated now than what I've seen. But yeah, pretty interesting to see how that last piece in there, you've got to have a pile of different sizes, and then you fit the size to the what the part needs.
So is he making them all the same at the same time, and then that tolerance is just changing as the machine and the material heats up and cools down? and then he sorts them out as he goes, and it's just like a production run, but sorts by tolerance.
Yeah. So, and this is going back way back in history in my memory, probably 5 years or something like that when I saw him. And my understanding was, and when I say, the parts might be a thousandth of an inch off, I think he was actually in the tenths range. So something might be minus 2/10,000ths of an inch, something might be minus 3/10,000ths of an inch. So
Yeah.
very, 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 very small differences. But when the parts would come off the machine, they would hit them with a micrometer and measure them and then sort them as the size they are.
Interesting.
And I
That's
think
like a whole next level type of thing.
he is very next level. Everything that he does is so far above and beyond what other people are doing. And that's what makes his product so special. And every time I have seen him post something for sale, it's gone about 3 seconds after he hits the enter button on the post key. There's a waiting list a mile long for his knives, and it's because of that. It's because he goes the extra mile, and some of the details on his knives and the fasteners that he makes, you can't see without a microscope. He's engraving logos with these tools that are the size of about 3 human hairs, and doing things of that nature, and really paying attention to the surface finish on things that are so small that you can't see them with the naked eye. And it's a whole different level, but it doesn't matter if your part fits in your hand or if it's the size of a car. You've got to have that tolerance, something to take that tolerance up if you want something to, from a craftsman perspective, to be at that next level and visually appear to be almost perfect.
Yeah, that's definitely some next level stuff, especially when you compare it to today's stuff that's manufactured overseas or whatever. Like, this is just a stupid example, but I ordered a pencil sharpener for the shop, and I wanted it to sit above my table saw, so I ordered one that had batteries, and then I have a whole bunch of rechargeable batteries that run the lav mic for my YouTube channel and the camera and all that. And I was just like, well, I'll just order some other batteries that way I can just charge them and swap them out as if it dies or whatever. Well, the rechargeable batteries have just this thin little extra coating on them compared to like a Duracell or an Energizer battery. So the rechargeable batteries don't fit in the pencil sharpener. The
Well,
tolerances were just too tight. Someone measured a Duracell and then made it exactly that.
you can bring it to my shop. We'll ream it out. We'll ream it to size, Brian.
Okay.
We'll make up for that tolerance issue that they have.
Yeah.
But I think, interestingly enough, when I started looking at it, and again, my background as an architect, you have to design things for, some people say designed with a caliper, drawn with a pencil, beat together with a hammer, and and all of these things to really explain what it is we're doing. That we try and draw these perfect things and then expect somebody in the field who has a backhoe to keep a dimension of a 32nd of an inch so that this building's coming together perfectly at a 90-degree square corner, or 22.4 degrees, or whatever weird skew that we've designed, right? And and all the time we're dealing with materials when we're designing in a shop, and something that's, call it the size of a desk or smaller. We deal with expansion and contraction issues in tabletops and things like that. We always make the drawer bottoms float a little bit so that they don't crack over time and things like that. When you deal with something the size of a building, can you imagine how much that thing moves over time? And we have to design for that movement, whether it's in brick, whether it's metal panels, whether it's stucco and drywall, cementitious type products, or you're going to see those, cracks start to translate from wherever there's corners and intersections, because that's the weak spot, right? And we have to design both from a construction standpoint, some tolerance in, and some fudge factor in. And then also from a material standpoint, we have to design it so that it doesn't pull itself apart when it gets cold and everything wants to shrink. And one of the ways that it's interesting how different it is today than it was when I started. When I started, um, I was literally 6 months after the last guy drew a plan by hand in our office. So we were in the hybrid mode right before I started. And when I started, everything was being done on the computer. There was very little being done by hand other than conceptual drawings sometimes were still done on a drafting table. And when we drew by hand, you would dimension an entire building. You would start at one end of the building and just go left to right. And the last dimension you would leave out because that was the one that you didn't know. These guys are stacking errors all the way through the building, and they might be off 3/4 of an inch or an inch or 2 or 3 inches by the time they get to the other end of the building, because they might set the first wall, but they can't set the 10th wall away from your original dimension until you get that first wall set. So they may not be able to go back to the very starting point, right? And they weren't using lasers or hot sticks or any of the stuff that they use now. And so you had to have a dimension in your plans that was that shock absorber. And you would give an overall dimension and people could work out the math if they had to have that dimension. But by and large, we were drawing walls 4 inches wide. There's no 2x4 and plaster drywall combination that equals 4 inches. It's 5 1/4, 5 1/8, whatever it is. I think, yeah, 2 pieces of drywall is 1 1/8 inches. A 2x4 is 3.5 inches. A metal stud is 3 5/8. So you get all these dimensions that aren't nominal anymore. And so we would allow for that. It was like, hey, we're going to design this loose. And if there's something in the field, if there's a plumbing pipe that doesn't get in the concrete exactly where it has to go, we've got to have that fudge factor. And that was always the last room. For me, it was always on the right side of the plan. And I would go from top to bottom. So right lower corner, that room didn't have any dimensions on it. And you would go from there. But then out in the field, it's very much the same way. Now, I think they can hold a much tighter tolerance over the overall dimension of a building is probably within 1/4 of an inch these days. It's very tight. And the reason being is everything has to integrate so well from all the different systems. And we don't have the young kids, right? I sound like the old man. The young kids who are drawing in the computer, they dimension everything because you click one button and it grabs every wall and dimensions it at the same time. There's no blank bay that allows for that fudge factor. So everything's a much tighter situation.
Interesting.
And what that leads to is exactly the problem you shared with the drawers. You get done and there's this one thing and you fight and fight and fight and try and figure out where the mistake was made. And by the way, it was made 7 walls down. and there's no way to push everything back. So now we have this room that doesn't meet the tolerance that we've designed to, because we didn't allow for that 2-inch filler panel in the casework in this final room, right? The day the job was awarded, there's no concrete poured, there was no strings on site or anything else to tell us dimensions. They went ahead and started fabricating cabinets because they knew they were going to fit, right? So it's interesting to see how that fudge factor has gone away and how we deal with it. So we deal with it a different way now. They remake that last set of casework, or they do something to take up that fudge factor.
Yeah, it's kind of funny to listen to you talk about that from the architecture side, because we work on two different sides of construction.
Mm-hmm.
You've spent most of your life drawing plans, and I've spent most of my life building the plans that you draw. And so there's always this joke on the job site that, oh, the architect, they don't have any actual experience, or the engineer doesn't have any actual real world experience. He's just book smart, so that's why it doesn't fit at the end. That's always the joke. Now, I will say 90% of the time it's because some idiot had something upside down all somewhere along the line, and we had to take it all apart to get it fixed. But yeah. So back to your walls having that little fudge factor that you left on the very end, leaving the last measurement off. When I draw plans for people to build some of the things that I build, or for like the Wood Whisper and stuff, we will always pick an end to start our dimensions from. So like we'll start at the top of the leg and we'll lay out the first mortise, and then we'll measure again from the top of the leg to lay out the bottom mortise for the bottom apron, and then the toe kick is whatever is left over. So that way you're always referencing off the same spot. And
Yeah,
then that toe kick or the leg or whatever is what takes up the air if there's any.
that's that's one thing I think everybody learns in their journey as they, as they begin building things is you have to measure from the same, you have to have a point of beginning is what they used to call it in the draftsman world. And you have to have that, and you have to reference that point of beginning over and over. Or as my grandfather, who gosh, he passed away when I was in high school, so I didn't get to learn everything I could from him. He was a self-taught carpenter, bought the Time Life books, taught himself how to build a house, built a house, and that's where my mom grew up. And I was listening to a conversation he was having with my dad when he was talking about framing a roof. And I can't remember what it was my dad was doing. Maybe my dad was building a garage, something like that. But he told him, he said, what you need is a pattern rafter. Start with that pattern and only use that pattern, because if you draw the next one and use the pattern on the roof and then use the second one as the pattern, it's going to start to grow or shrink, whichever way. And by the time you get to the other end of your roof, you're going to have rafters that don't match one another. And it was, you know, a little bit of a, I remember being young when I heard it, but it was a light bulb moment that how to use a pattern or how to set something, because those tolerances will stack up together and they'll kill your project at some point. And it was just interesting to hear him sharing that with my dad, and kind of getting to hear that. But I think all of us who build things have to have that light bulb moment at some point, and you hope it's just as early in your career as it can possibly be.
Yeah, like that has happened to me before. I had my pattern and I used it to mark my piece. I made the cut, and then that work piece I used to mark the next piece and make the cut. And that pencil line just kept growing instead of using the first one as my pattern and carried it all the way through. That's gotten me in trouble a few times. I just or I'll
I,
get confused. I'll forget which one was my pattern because I was lazy and didn't mark it, and then I'm just guessing this is the one, and then it wasn't the one.
I would love to have, you know, 5 or 6 guys in a shop and say, okay, we're going to do this. We're all going to cut 10 boards, and you're going to start, the first one's going to be your pattern. And then you have to use the next one as your pattern all the way through, and see who could get the tightest tolerance doing it that way, and see how far off you get after
How much
10
it
cuts.
grows. Yeah.
That would be kind of a fun experiment to do.
Yeah. So another good example of the architecture and the builder or engineer and the builder relationship is uh, a long time ago, I was a manager for a design build firm, and we specialize in designing kitchens and baths. And the tile layout, most of the time, we would just mark layout from center of the shower, like from that back wall, you lay out from the center out to the sides. And one day I went out to the job site and he had done exactly that, but the tile didn't work out very well. So there's this little sliver on both sides. And so I was like, oh, that's not good. And luckily he hadn't got the whole wall up. So I was like, hey, let's take these off and start over because that little sliver on both sides isn't going to work out well. And so then I showed him like, let's just shift it over a little bit so you have a full tile on the wall that you face, like when you're standing in the shower and the water's pounding on your back. Let's put that fudge factor on the side that you're not ever going to see. Or then maybe try, instead of centering on the center of the tile, centered on the center of the grout joint and see how that lays it out. So let's play with the layout first before we start spreading the thin set. And then after I had that conversation with them, we never had an issue ever again because he just like, oh, that was his light bulb moment. Like there's another way to lay it out, even though it says layout from center, because that's just kind of the standard thing, because of course you want to have it centered whenever you can, but sometimes that tile's not a perfect 4 inches or whatever, especially on some of those um, clay, like Mexican clay tiles that are
Yep.
handmade. They say 4 inches, but since they're all handmade, they shrink a little in the sun or whatever. So yeah, after I showed him that, then he knew what to do every time, and then we had awesome showers every time after that.
There, there is a ongoing battle between architects and engineers when you're designing or laying out a ceiling in any given space. And it's exactly what you're pointing out there. When, again, when you're drawing by hand, every line that goes down on a page is a decision, right?
Mm-hmm.
You have to start with something in mind and draw it and then look at it and go, okay, I do or don't like this. And the fact that you have to erase a mistake, like physically erase a mistake, makes you think about things very hard before you put a line down if you have to erase it and redraw it. Using the computer, you don't have to think nearly as hard, right? You can actually, in the programs we use, we can just say put a ceiling into this room and it poof appears. You don't have to draw a single line, you just have to point at it and say make a grid there and use 2x4s in this direction. And you can slide those lines around, and usually we do, and we look for exactly what you're saying. If you have a sliver of a tile at either side, then you move it half a tile off. The engineers come in and they want to light this room perfectly, just like they show in the textbook. And sometimes that means they want their light to not be just half a tile away. They want it a full tile away. So they'll they'll come in and want to shift the grid over to where it has that thin little chiclet on the side of the grid. And it's like, oh man, this is just going to look wrong. Well, it's going to be lit wrong if we don't do it this way. And there's this constant struggle with our design engineers to just say, you know what? It's okay if the light isn't textbook perfect. This room has to look nice. It has to be visually appealing when you go in. So kind of an interesting battle that I see over and over again.
Yeah, that is kind of funny. I'm sure there's a solution there somehow to make it all work out, like maybe fudge it over 3/4 of a tile or something. But then you got to have everybody to buy off on that, and that's sometimes hard to get.
We actually, and I'll share one more story and then we can get off of this topic. We actually are working on a school right now that they started at the exterior wall with a full ceiling tile, and they laid out the walls, the studs, they laid out the studs to a 4-foot dimension. So these tiles kind of march across the ceiling. And unfortunately, they had to put 5/8 of an inch of drywall on this wall. And so when they finally hit the wall, they were 5/8 of an inch shy of a full tile. And they wanted to put a light in that last tile, and the light wouldn't fit. And the way the room is laid out, there's kind of a notch in the back of the room, and that notch is where this happens. And they needed a light to land there, and they couldn't get it. So they wound up, for some reason, I'm trying to picture it in my head and it's just not coming to me, but they had to rotate the light fixture 90 degrees. So there's one light fixture in the back of the room rotated to 90 degrees to everything else on this wall that's off 5/8 of an inch. And it's a perfect example. One of our architects was there with us, and she's got plenty of experience and understand why this happened, but we still had the conversation. This is why you don't design with a full tile on an outside wall and expect it to march across a room and fit perfectly. There's no way anyone should have ever designed it that way. They should have designed it, with the edge tiles being equal on both sides so that it would make a nice lighting grid layout. So the conversation was, we're renovating that building, and the conversation was, do we leave this one weirdo 90-degree fixture? Do we eliminate it? How do we solve this problem so that for the next 30 years we don't have people asking this same question?
Yeah, and everybody points up, look, that guy screwed up. He didn't know what he was doing. It's all crooked now. They're going to point at it every time. Yeah, so I know you wanted to move on, but that made me think of another thing from a custom standpoint. Most everything I build is custom. and have being in the position where I've installed like those acoustical drop-in tiles, those things are just snapped on there, and then the acoustic tile rests in it. So you have a little bit of the person that installs that has a little bit of fudge to move that snap over just a little bit. So they may not even intentionally mean for it to end up a 5/8 inch off on one side, but they could have possibly spread all those back out, but that would have taken a whole lot of extra labor to do. But there is a little bit of wiggle when you snap those cross beams on there, because it's just this little metal aluminum thing and they snap together, but each one has a little bit of a wiggle in it.
Well, I know I've been on the rotten end of that in that um, my dad was an electrician. So growing up, I did electrical work. I started working with him on commercial sites at 12 years old, which I can say that now because the statute of limitations is expired. But I started doing commercial work with him at age 12. And, you know, a huge part of doing electrical retrofit repairs, things like that in commercial buildings is lifting up those ceiling tiles and getting above there and doing your work. And you could always tell when somebody had fudged the grid a little bit because that ceiling tile just wouldn't push past the lip. And it was always a trick to get it to sit back down in there because those are most of those grids are fairly tight tolerance, you know, within probably 1/8 of an inch or less. And that was definitely a rite of passage as a young man, understanding how to get a ceiling tile to sort of fold and taco and land back down in the grids that somebody had fudged a little bit.
Yeah, the best ones to install were the ones that had like this texture in it, because if you couldn't get it to pull down tight, you could put a screw in one of the dark texture points and then pull on it to get it to come down tight. Did that a few times. But
We
that's
I
one of
don't
the little
think
tricks of the trade.
I don't think we ever did that. My trick was always to bang on the grid so that the grid would go up and create a
Oh,
little
there you
bit more
go.
room
Yeah.
and the tile would pop down, and as the grid came down, everything would sort of snap together.
Yeah, that probably worked pretty well on the grids that were suspended by the wires.
Mm-hmm.
Yeah.
Yep. Oh man. Yeah, a lot of fun. Holy cow. But well, let's see. We've covered some good stuff. We've covered some architecture, some carpentry, some guitar building, and I mean it's very interesting as you look at design and you look at construction, noting the fact that if you don't plan for the chaos, so to speak, the chaos will happen to you in ways that you can't control. So you know, we always say at work, you can't control all the chaos, but you can generally control where the chaos happens. And I feel like that's definitely something that happens in the construction world, the making world, and the design world.
Yeah, I think I have one more example that we haven't really touched on, and that's order of operations.
Oh yeah.
So this is something that's I've stressed a lot in my current work. I do a lot of built-in bookshelves, and the first time I worked with this one particular builder, he was worried about the tile guy scratching the woodwork, and so he wanted the tile guy to put in his fireplace surround, and it was a stone veneer, and wanted me to excuse me, wanted me to ascribe the wood to the stone veneer, and I was like, that is a crazy amount of work to make that look good, to scribe all those little bumps on my built-in bookshelf. I was like, how about I come in first, and then all the tile guy has to do when he wraps around the corner is cut a straight cut on each tile. And the contractor was really like pushing back on that because he was so worried about the scratching thing. And I finally had to tell him, like, look, dude, if he scratches it, I'll come back and fix it for free. I'll refinish that for free. It's not a big deal. It'll be way easier for me to refinish that than it is for me to scribe all those little bumps. And so that order of operations, I think, is a really good place to hide your fudge factor.
Well, and by the same token, one of the things that it's sort of the unsung hero in the architecture world is the caulk joint. And if it's an afterthought, it's usually pretty terrible. People think that caulk is a waterproofing agent, and it's not. It's a gap filler. Keeps bugs out sometimes, but by and large, it's there to absorb a little bit of tolerance and give you some wiggle room. And again, if you don't design how those joints come together, they're going to sneak up on you, and it's going to create bad details, and it's going to create problem areas within your building. But if you really pay attention to how door frames and walls and bricks and all those things come together, and you can plan, I'm picturing what you had in your head, but if I were designing tile coming around a corner into some, wood detail of some sort, I'm probably leaving a 1/4 inch gap there to fill with some kind of flexible sealant to take up whatever that is. And it's going to look great because you planned it. And it's going to be a nice
Right.
straight line. Where a lot of people fail in that design is they're literally butting the two things up together, and there's no room for any soft joint. And when there's no room for a soft joint, usually the painter or the finisher comes in and caulks in the corner, and those joints never hold up. A tight joint that has caulk in the corner does not hold up. It will be cracked and ready to pull back out in a month or two because you didn't plan well for it. But interesting. Just I could think of a million different examples on different jobs that we've done where I'll be on a job site and something doesn't fit together right. And you take a look at the plans and details, and it's like, oh, somebody forgot to detail this one little thing that could have made this joint really well detailed. So
Yeah. So now that brings another question: is it possible for you to over detail to where you're stepping on the craftsman's shoes? Like he has his way that he knows, like I've never gotten a call back doing it this way, but the architect is detailing it me to do it a different way. Do you get people sending you change requests? I'm sure there's a industry standard term for that.
yeah. So the way that commercial architecture works, some residential does, but not all of it, is during the construction process, contractors are submitting shop drawings to us. And just to throw it out there, architects have to be experts on so many different varieties of whether it's materials and details and systems and all these things, right? You're sort of the jack of all trade, master of none. And you really do have to rely on the craftspeople to tell you what's the best way to do it. They're the ones who have to honor the warranty. They're the ones who have to install it and, stand behind it at the end of the day. So we draw it in the way that we think we want to see it. And in general, you want to account for all of those aesthetic things that you know about. You want to account for any failure points to, shingling is a big thing, like shedding water and stuff like that. You have to design the building in such a way that it's technically going to work. After that point, when you get to a spot where it's, potato, potato, tomato, tomato type of thing, you really do have to rely on the craftsman. And that's where the shop drawing process comes in. So one example that I would use when we do metal roofing details, whether that's copings or parapet caps or a metal standing seam metal roof coming together with a head wall or something like that, I can't tell the guy how to bend the sheet metal. He knows how to do it. He's been trained a certain way, or he or she has been trained a certain way to make that detail work. So what they do is they look at our drawings, they look at the intent of our drawings, and then they send us back a set of drawings that says, here's the details that we would like to use. And generally they will outline where there's a large difference. If it's a small difference, hey, it's 4.5 inches versus 4 3/4, probably not a big deal. But if there's a large difference, they usually point it out and they say, here's where we think we can either save some time, some effort, give you a better detail, some value out of this difference in detail. And then our job is to review it and say, does it meet the intent? And then is it going to work? Do we think that's really going to work? Sometimes that's done in the field, literally as you're walking out there, the sheet metal guy might be there and say, hey, can I bug you about X, Y, and Z? Yeah, okay, sure. Other times it's through shop drawings and Sometimes it's through phone conversations. Hey, these guys are working on something. You've designed something they can't build. That happens all the time. And sometimes it's a simple explanation of, well, maybe you didn't understand the drawing and here's what we really meant by it, because you're drawing a three-dimensional piece in 2 dimensions, and that doesn't always work. It's not an easy way to communicate. And other times, you explain it and you say, yeah, this is how it's supposed to work. Oh, okay. We thought you meant this. Okay, great. And other times you explain it and they go, yeah, that's the problem. It won't work that way. And so you sit and you rely on, again, their expertise. They do sheet metal 40 hours a week or 50 hours a week or 60 hours a week. And, we don't. As architects, we draw it, and, you take a series of days to draw your sheet metal details on a project, but then you may not touch sheet metal for 4 or 5 months. So they're definitely the experts, and we have to lean on them quite a bit.
Yeah. I have one more example of working with a contractor that got me in trouble that involves a caulk and meeting a ceiling. I did this built-in bookshelf, and it was 12 and a half feet tall. So I couldn't just get plywood. So I had to veneer up this long thing to make the end pieces and end caps work. And I wanted to hide my discrepancy in a little trim piece along the ceiling just to clean that up, and I could scribe to the ceiling and it would look nice and clean and neat. He didn't like the trim piece. He wanted it like the wood just come straight up and terminate into the ceiling. So it was a huge pain to scribe all of that um, panel to the ceiling without a trim piece. And I got it all up there, looked great, and it's fine. A year later, I came back to do some warranty work on a door that was sticking. It's just because I custom built these doors for this house too. It was this crazy job, and so I go back and I look at this bookcase, and the weight of the wood had sagged down to where now there was this gap, and it just looked like shit. But yeah, so while I was there, I just offered to caulk it for him, and got it taken care of. But I just thought, yeah, that's a situation where I wish the guy in charge would have listened to the guy that's building the thing. But
Well, and I mean, just again, anytime that two materials are supposed to butt together like that, you have to allow, especially in residential construction, you've got wood studs that were in a growing inside of a tree for 20 years. You cut them into these planks, and then you put them into a house, and then you turn on the air conditioning and the heating and everything else. And there's no way that's going to be a dimensionally stable thing, right? We don't generally build houses with metal studs. Those are fairly consistent, but the wind blows and everything else happens and those houses move around. And a shadow line or a caulking joint or a trim piece or something, there's a reason those have been around for thousands of years. And it's because our buildings aren't, even concrete buildings move, steel buildings move, they all move. And if you don't plan that fudge factor in, there's absolutely no way that it's going to look good other than the day you put the last coat of paint on it.
yeah, that fudge factor of movement is in everything. Back to my bridge construction days, when you're driving down the highway and you drive over a bridge, when you enter the bridge and exit the bridge, you'll hear your tires go thump 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 thump, and that's because there's an expansion joint at the start of the bridge and the end of the bridge because that bridge is moving
Yeah.
with a change in heat and humidity.
Yeah. And sometimes on bridges, the expansion is pretty massive, 3, 4, 5 inches sometimes. And holy cow.
Yeah, I think we've beat this topic to death here with some good examples.
We've had some great conversation about, you know, planning for and not ignoring and sticking your head in the ground, thinking that you can work through these tolerance issues without planning for somewhere in your project to absorb that fudge, as we call it, and acknowledging that and intentionally designing to it will make your project so much better.
Yeah. All right. Well, thank you for listening. This is the Maker's Quest podcast. I'm Brian Benham.
And I'm Greg Porter. Thanks for joining us.